Hi, this is John from 3D Focus TV. Now today I'm actually in Shepperton Studios, and the reason I'm here is because I'm with a company called Axis Films. Now Axis Films have had 20 years experience in producing HD content, but they've actually moved a lot more into 3D content now, and they hire out 3D equipment. Now I've been kindly invited here to a place called the 3D Centre, which is just opposite, and I'm here with Richard Mills, who's hopefully going to explain how some of this technology works, and in layman's terms anyway. So could we start off by looking at this? What type of 3D rig is this?
Well, this 3D rig is known as a mirror rig or a beam splitter rig. The whole idea with 3D is to capture a left and right eye image and then superimpose them on the screen, so that we get the perceived impression of depth within the picture. And the way we achieve this is by using two cameras, one for the left eye and one for right eye. And it's quite important to get the distance between those cameras correct for each scene. And this is where a beam splitter comes in really handy, because with a beam splitter you have two cameras, one for left eye and one for right eye here. This is very difficult to get two large cameras close to each other. What we do is we use this mirror rig or beam splitter. So the image from the top camera is reflected off this mirror here, which is at 45 degrees. Mm-hmm. The image from the horizontal camera here shoots through the mirror. And by adjusting these cameras from side to side, we can actually make the distance between them correct for the particular 3D depth of the scene.
Okay, so this is called a beam splitter. The alternative ones would be side by side, but the advantage of this is that you can have the camera lenses far closer together, much closer together. You've actually got a setup over there. Could we have a quick look at that, and it will hopefully show a bit clearer how it works? Okay, so what have we got here then?
Well, this is a much smaller mirror rig. You see, it's got the same component parts. It's got a camera looking through.
Camera's there.
There's the camera there, very small camera in this case, looking through the mirror box. And it's got a camera here reflected off the mirror box. So if I put it up here and I actually control dynamically this situation, I can actually adjust the distance between the cameras here. You might just be able to see.
Oh yeah, of course. Whatever you're going to close it, you can actually see the. So this camera is being reflected off the mirror. That's coming up.
Camera's through.
Because it's almost like a two-way. Two-way mirror, one way.
It's a half silvered mirror.
Half silver mirror, right?
Very accurate half silvered mirror. Right. So for a scene which might have objects very close to the camera, you need to have the distance between the cameras, the interaxial distance, very, very small. For we have a scene where there's a fair amount of distance between the subject and the camera. You can have the cameras further apart. So with this one here, we can get a distance of about 4 or 5 inches apart, and or alternatively, exactly overlaying each other.
Great. Okay. So, in terms of how you decide whether something's coming out of the screen or going into the screen, how would you adjust something like that on a rig like this?
Okay. So let's say we've got a scene with our nearest object about 1 metre away, and the furthest object is say about 10 metres away. We look at the lens angle we're using, we look at the size of sensor we're using, and we also judge by the size of screen we're going to display it on. We make a calculation based on those factors. When we're doing stuff for the small screen, the distances between the cameras can be slightly further apart. It's more critical on a large screen where you have a bigger screen size to make sure that the maximum distance between the two images that you're trying to get your perceptual system to fuse together is not too great. So that calculation really for that scene where we have a subject about 1 metre away, furthest subject about 5 to 10 metres away, will be somewhere in the region of 25 to 35 millimetres, depending on the capture format of the camera and the lens we're using.
Okay. And how do you monitor a 3D production? And I mean, I've seen clips when they filmed Avatar, and you have two screens. How are you able to monitor?
Perhaps we can demonstrate on this one here. We've got a 3D monitor. We've got a 3D monitor attached to this rig here, and we can monitor either the individual eyes.
Yeah.
If I just select here, or we can monitor a 3D view. Let's try and angle that around so we see something. So what we've done here is we've turned the picture monochrome. Okay. That's the first thing, and then we've highlighted the left camera in red, and the right camera in green. So as I move them further apart, you might be able to catch their red and green edges. So that's the two images overlaying each other, right? And that's the images separate from each other. So that way we can tell how far they're apart. They also have a number of other tools as well on here. This is a very useful monitor, actually, more of a technical monitor, but also very practical in the field. We can actually overlay a grid with it, quite difficult to see at the moment, that's measuring in percentage terms the disparity between the left and right eye image. So if I've got there, we've got it dialed in here, 2%, so I know there that the error I'm getting is 4%, which is probably going to be too much for the 3D of this scene.
Okay.
And so we're monitoring the output of the two pictures there in a mode that we can assess whether or not everything in the scene is going to fit the depth budget that we're aiming for.
All right, and the last couple of questions. How much would a rig like that be to buy? Not forgetting the cameras, but to actually buy a rig like that.
Somewhere, the starting point really is about $50,000 US, but on top of that you've got an amount of ancillary equipment which is essential to get it working. Power distribution and servos for the lenses. Also as well, you've got to have something fairly sturdy to mount it on. This rig weighs around about 40 to 45 kilos, depending on what camera you've got on it, even higher with some lenses. And it's very important that you choose a head which will actually support the weight of this, and more importantly as well, not only support the weight in a static basis, but also if you want to tip over,
Right.
you want to tilt the camera forward,
Good.
that it will hold the weight of that rig at any angle.
Good.
So this one has a tremendous amount of balance built into the rig to be able to handle that. So you can in fact tilt this right up or right down.
So you wouldn't be able to use my tripod over there for something?
No. The centre of gravity of this particular camera is somewhere about, this rig is about here.
Yeah.
So it's a tremendous amount of over-centre balance that the camera head has to handle.
So hence, that's why I guess you're growing quite quickly, because people don't have to buy them, they can just hire them off you, and
Yes.
hence it makes a lot more sense to hire, doesn't it? Well, that's great. Well, I'm going to come back to you and give you a quick fire round for technical terms that I want to know about, but I think now I'm going to speak to Andy Shelley, who's the head of development here, and ask him a few questions about the 3D industry as a whole. Okay, well, I'm now here with Andy Shelley, who's head of development here at Axis Films, and I'd like to thank you first of all, Andy, for inviting us here today. And I'd just like to start off by asking something a bit more general, really, about the 3D industry. And one of the questions is, are we beginning to see less extreme 3D? And when you're involved with a 3D production, are you always aware that this might need to be shown in 2D, and do you find that restricts your creativity?
I think with regards to extreme 3D, I think there is a distinct move away from it. I think for the world of short form material in a theme park is okay. I think that's fine. I think when people are watching at home and they're starting to watch longer form programming, you need to make it comfortable for people. So having something which actually becomes quite hard work. So things coming in and out of the screen, lots of depth, lots of negative things coming out of the screen at you becomes quite hard work, and it makes people tend to feel quite uncomfortable. So people like Sky have definitely taken the right opinion to things, and they've made specifications which limit the amount of shots that can come out of the screen and how far into the screen you have your material.
Great. Now, earlier on today, you told me that you have quite a good relationship with Sky, don't you? You've been working with them quite a lot, and you've been involved with a documentary recently called Flying Monsters, which is going to be coming out at the end of this year. Can you tell us a bit more about that and what that involved, and what the challenges were with that?
Yeah, that's been a big show for us this year. It's going to be on Sky on Christmas Eve. It's going to be a piece with David Attenborough, so it's about dinosaurs flying, prehistoric dinosaurs flying around. It's live action combined with lots of CGI as well. We've flown all over the world filming locations, which has been incredibly interesting. But yeah, so that's going to be something for later this year.
Great, and also I heard that you're doing something with meerkats as well for Nat Geo.
Yes, that is another. That's going to be next year, actually, for summertime next year, and that follows on from the successful franchise of the Meerkat series. So that'll be a meerkat film in 3D. So the guys are out currently filming in the Kalahari, and we'll be going into post-production February, March time next year for that one.
Because you were involved with the world's first live 3D sports broadcast a few years ago, and it was a rugby tournament. Are there any other genres you think lend itself well to 3D production? Because there does seem to be a large emphasis at the moment on sports, particularly with Sky pushing sports and the French Open tennis filmed in 3D and everything. Why sports in particular, and is there anything else you think would work particularly well?
Sports is an obvious one. I think Sky are very clever. They put a lot of research into filming sport in HD when that first became a platform, and it worked successfully. Worked very well. And for everything I've seen, the sport works fantastically well in 3D, and they've been doing a lot of research and development with suppliers in that space, such as Telegenic, to make sure that they've really kind of nailed that side of things. I think the other genres which we found particularly interesting and that we work with clients on, the natural history one is an obvious place to start. I think being able to show people an environment in stereo in 3D of where animals, natural habitat for animals, can be incredibly interesting. Other areas, music, I think, to give people an immersive experience in with their favourite artist, that's an interesting one. And the commercials market, there seems to be lots of commercials and corporate companies working to really kind of help people sell brands and ideas and market things in that way. So it seems to be 3D seems to work in most genres. I haven't been proven yet to, no one's come along and said, will it work in this way in a particular genre, and for it not to have done so.
I'd just like to wrap up now by asking you some quick technical questions and just some of the terminology used in stereoscopic production that some people might not really understand. So I'm going to go through a list now, if you don't mind. First of all, what is a P&S rig?
P&S is a manufacturer. They manufacture 3 rigs. One is the universal, the second is the small side-by-side, and the third is the freestyle, which is actually quite a good handheld rig.
Great. Okay, what does I/O mean in the stereoscopic world?
I/O is an abbreviation for interocular, and it's the distance between our eyes. The distance between 2 cameras is the interaxial distance.
What does being capable of overthrough and underthrough mean?
Well, these are terminologies used by a couple of American rig manufacturers. Basically, you have 2 cameras and a mirror rig. The under camera is the one that's underneath. The through camera is looking through the mirror. Or alternatively, the top camera, if it's upside down, the top camera is the over, the bottom camera is the through.
So like we saw earlier on?
That's right, yes.
All right, and we just saw a few 3D clips, and you mentioned a feature called the handover, which helps people adjust to the depth of 3D going from one shot to another. Can you just explain what the handover is?
Yes, if you're trying to cut between 2 shots, one with a depth budget that's different from the other, or a point where the screen plane is different, you can actually merge the depth of the outgoing shot to the depth of the incoming shot. That's known as a handover, handing over from one cut to another. And
you can see that if you don't have your glasses on, you can actually see the image sort of slightly change. It takes about half a second, doesn't it?
Yes, in the process there's one of 2 things, or both things happen. One is you shift the convergence point to alter the screen plane on the outgoing shot. Alternatively, you can narrow the depth, i.e. the distance between the disparity between the outgoing image to match the incoming image.
And finally, what does positive and negative 3D mean?
Okay, this refers to where objects are perceived to be. So positive 3D means actually past the screen into the beyond the screen plane. Negative disparity means out towards the cameras.
Perfect. Well, I hope that's made everything. That's your quick guide to stereoscopic production. Thank you, Richard Mills.
Pleasure.